So thank you everyone for joining in on the webinar today. This webinar about circular agriculture in the Netherlands. This seminar it's a continuation of the UNC Clean Tech Summit that was held this past February. Our keynote speaker today is Saskia Visser, and she's joining us from Wageningen University, where she steers the strategic research agenda for the university. Saskia, in her research, she integrates the physical process-based research with social learning and participatory policy development. So she's working on topics like you're going to hear today: circular agriculture, sustainable food production, climate, smart soil and land management, and land use optimization. So in today's webinar, what I'd like to ask the audience to do is to please take advantage of the Q&A button at the bottom of the screen. So we're going to use that to help answer questions. We're going to be answering questions throughout the seminar. Dr. Visser will stop at certain times to answer questions that I'll read and help moderate. So we'll also answer, there were several questions that were sent in earlier, so thank you for doing that. And we'll also answer that, those questions as well as we go through. So that being said, Dr. Visser, why don't you go ahead and take over?
Okay, Susan, thank you very much. Well, my name is Saskia Visser. I'm the program leader of the knowledge-based program of the transition towards a circular climate neutral society in the Netherlands. And I will give you today some examples about the introduction first, to start with the agriculture in the Netherlands. What does it look like? Some information about transition management, and then the definition on circular agriculture. And I will give you some examples of our research that we currently do for a circular system for open cultivation, greenhouses, and animal production. And I would like to address all the inputs provided by my colleagues, because I do not do the research myself, but I have many colleagues within Wageningen providing the building blocks to realize this transition. The Netherlands. It's a tiny country situated in the northwestern part of Europe. We have 17.1 million inhabitants, and it's actually 237 times as small as the US. And you may know the Netherlands from Amsterdam, obviously, but also from its flowers and from its windmills. But actually the Netherlands is a very green country. Despite the high population density, we have a lot of green areas, and we have a very favorable climate for agricultural production, and our soils are also very productive. And that all results in an agricultural production export that is worth approximately 94.5 billion euros in 2019. And that brings the Netherlands the second export country of agricultural products in the world, just after the US. The export consists of primary products, but also of agricultural goods, and approximately half of this export goes to, well, the northwestern part of Europe, so Germany, Belgium, the UK, and Denmark, and the other half goes to the rest of the world. Well, to sum, in 2018, the Netherlands was the #1 producer of onions. So quite a big chance that you have once eaten onions from the Netherlands. We have a very well-developed greenhouse horticulture system, and also the largest auction in the world of flowers and plants. The seed sector in the Netherlands is very productive and very successful all over the world, and we have produced a large variety of trees and shrubs that are planted all over the world. So that's the very positive part of the Dutch agriculture. However, in the Netherlands, we also have problems with our soils. Heavy machinery resulting in soil compaction, We have, specifically in our peatlands, we have submerging soils. So this is a bunker constructed during the World War II, so 75 years ago. And at that point, the soil would be at the level of this entrance. So this would be 1.5 meter of soil disappeared through peat soil disappeared to the air, sorry. And the Dutch milk is very known all over the world, but milks are produced by cows, and that means that we have a lot of manure in the Netherlands as well. Well, combining all this system came to the level that the realization that in the Netherlands, our agricultural production system is no longer within the planetary boundaries. And that there is an urgent need to change our agricultural system despite of the well-produced economic position that we have. And well, for me personally, it made me very proud that to be Dutch, that when our ministry became in 2018 with a vision on circular agriculture. It's a vision that builds on a transition towards a new system, and it entails a paradigm shift from growth in production volumes, continuously reducing cost price towards an optimization of resource use and food production in harmony with nature. So we look at an agricultural system where all the cycles of the substance are closed. And this means that these substances that are disappeared because of agricultural production should also be returned to the area in a certain way. Well, that's obviously nice to have it as a vision, but now let's have a little bit a closer look to that. What does that actually mean? And I think agriculture starts obviously with the reason why you produce agriculture, because because humans are in need of biomass, and they are in need of biomass for food, but also for non-food products like clothing, like electricity, like construction of a house, for instance. And this biomass is being produced at our arable lands and in our natural waters, in our oceans. And that's the first assumption of the agricultural system, is that we should use our arable land for the production of food for human. And I think this is a very important consideration, because it means that we do not use our arable land to produce feed for animals. So that's the first consequence of thinking in a circular agricultural system. Then, while producing this biomass from arable land and from our oceans, always side streams occurs. These side streams can be in the form of crop residues or from co-products resulting from the processing of foods, from food waste, but also even human excreta are considered to be co-products or side flows from the food production systems. And these side products should all be brought back into the system, either as a soil improver or as feed for our animals. And I think that's the second important change in the whole circular system, is that animals have a very specific role in a circular agricultural system, because animals are used to transform side streams into high value proteins for food, into manure, or maybe into other ecosystem services. Then obviously we need more biomass, because we also need biomass for our non-food products, for our bioeconomy, like clothing, like electricity, etc., etc. And also this biomass is being produced partly from the natural waters, partly from the arable land, from the grasslands, and from the forest. Well, thinking about this whole system brings along all kinds of scientific questions, like, for instance, what crop rotations on land are effective to restore soil health, effective to produce sufficient food, but also effective to produce side flows that are good for our animals. What is the biomass potential that we can obtain from the natural water, from the ocean? And at what scale do we close this whole system? Do we do that at the scale of the Netherlands or at the scale of a farm, which by principle is not possible because a farm is there to produce agricultural products that go out of the system? Or do we do that at the scale of Europe? And to which extent will that, as a consequence, have an impact on the in- and export position of the Netherlands? Finally, we want to make sure that we do this in a safe manner, and to introduce food waste into animals is a very delicate question, because you do not want to create all different kinds of diseases which may occur when introducing foods into as feed for animals. And also bringing the human excreta into the whole system brings all kinds of safety issues along with it. And then finally, how do you start such a transition to a whole new agricultural system at the moment where you already have a very well working agricultural system in place? But for that, I would like to, this is another point that we need to do, because to remain within the planetary boundaries, we do not only need to make sure that the circle of substance, and we focus on resource use efficiency, we have to do something more in order to restore the climate. So we do have to work on carbon capture in the whole system as well. Well, to answer the questions, how do we start such a transition? I would like to show you some information about transition management. And transition management is there to, it obviously starts with a vision for the future where you want to go to. And you can bring that back to set up scientific questions for research, for experiments that you need to execute. And once these experiments are successful, you can start thinking about how do you accelerate the scaling up of the successful experiment, such that you can adjust policies or laws to reach the new normal system. I think, for instance, the emergence of mobile phones can be seen as starting from an experiment, a lot of people buying mobile phones, as such at a certain level, new laws were needed to assure that the cost for using such a mobile phone would be not too much. And now everybody is using a mobile phone, so this is the new normal we move to. I think following a pattern like this is only possible where there is not a system at present. And in the Netherlands, we already have a very good agricultural system present. So therefore, you need to start thinking about how to break down, or how to make sure to facilitate the replacement of the current system with the new system. And that's where you also have to think about different processes to support this transition, which means you have to apply corrective barriers for current systems. For instance, you start thinking about, okay, if you want to have this nature inclusive circular agricultural system, what about the use of pesticides? Our ministry has already said by 2030 we want to have significantly reduced the use of pesticides, and we want to totally abandon the use of fossil-based fertilizers. So this means that we already can start thinking about cropping patterns or rotations that do not need these pesticides, or alternative for pesticides and alternatives for fossil-based fertilizers, such that the new cropping systems are no longer dependent on current practices that are available. And finally, you want to be able to phase out the current practice. In the midst of this, the transition towards the new normal, it's normal that you will create some chaos. And I think in the Netherlands, we are currently in a position where we have some chaos. farmers are no longer aware of, okay, what should I invest in? They feel locked into a situation where it's very hard to get out of that system and start producing in a different way. And therefore, we need to adjust our subsidy system, adjust our laws, such that emergence and the transition towards a new system of agriculture becomes possible. And the first thing that what our ministry did last year was to set up a plan to show some concrete actions for the direction we want to go to. So instead of transition being only a concept, circular agriculture only being a concept, she made a plan, okay, make sure that we know what it looks like and what is needed to do that, to do this, and to find some focus for our research and innovation. So she says, to assure the realization of circular agriculture, we need to make sure that circular agriculture requires a solid economic base for producers. So you should be able to make a good living out of it. It says, make sure you have a commitment to knowledge and innovation development. And make sure that the appreciation for food and food producers becomes high again, such that farmers are valued at the level where they should be valued. Make sure you develop favorable legislation, and of course, make sure that you have a good balance between agriculture and nature. So it started with these concepts that we moved forward into practice and in doing research together with the stakeholders, together with the farms, research also on the farm, to make sure that our research does not only remain a theoretical research, but it's directly applicable into practice as soon as possible. So this is what I have to say about the theory of circular agriculture system and agricultural production system. So maybe you have questions already. Susan, did you get?
So I have, I'll confess, I'm not so sure the Q&A is working so well, the button. So feel free to type in your questions also on chat, the chat function on the bottom. That's fine as well. We have some questions that came in earlier, and I'll just ask one of them. Somebody was asking specifically about how you're incorporating the human food waste or the human food wastes into the animal feed.
Yeah.
How do you feel like that's going to work?
Yeah. At this moment in the Netherlands, there is legislation not to use human food waste directly from the human plates for animal feed. And that has a lot to do to avoid cannibalism, for instance, to make sure that no meat leftovers are fed to pigs, for instance, or to cattle, to avoid all kinds of diseases. There are some food wastes directly after processing that are already used as pig feed or as poultry feed. One of the trials that we are currently doing is to feed insects from food waste, and actually they are doing very well. And then these insects, we check the microbiomes of these insects to see to which extent they can be fed to poultry, which then can be used for human consumption again. So this is one of the pathways that we are currently using.
Mm-hmm. And how do you expect that transition between 2020, 2030, which is this possible period of chaos, how do you expect that to affect the 94.5 billion agricultural export market?
I think in the transition phase, we will remain quite high on the export value, export position. However, with the current COVID crisis, things may change very drastically because we are significantly reducing export values already, what we're seeing at this moment. I think the overall export will reduce. Specifically the export of biomass products all over the world, but I think we will much more increase in export on equipment, agricultural equipment, and all kinds of innovations that are needed on that part.
Okay. Good. So somebody is able to use the Q&A, so that's great. Glad to see that it's working. So to what degree has the Dutch government embraced the transition, and what are some of the actions of the different interest groups?
Well, it's a transition which is stimulated by the Dutch government. So actually at our Ministry of Agriculture, Nature and Fishery, we have strategy implementation groups. So we are sure we have a real ambition to reach those goals by 2030, and by reaching circular agriculture, we assume that for the agriculture part, we also will have reached the climate goals and the nitrate perspectives. So all different goals come along with these goals. What do you see from the different groups? You see a lot of, it started pretty positive. Farmers started to embrace the whole idea of circular agriculture. Also, the large chains started to embrace, and now you see some people, well, kind of resisting because they want to know much clearer where are we want to go to and what will be the consequences for their companies. And this is where you reach where you are in the midst of this chaos. So it's very important to make sure that this dot on the horizon is soon as clear as possible in order to make sure that the people are able to follow.
So that gets to a question that came up here in the chat is, which of the stakeholders in this transition are most resistant to this change? Is it governments, farmers, food processing?
At this moment, I would say some of the farmers. Not all farmers, but some of the farmers are being resistant. You see specifically young farmers being pretty enthusiastic about it. However, they do say, okay, make sure that we can start in a good way, such that we do not have to have tremendous loans. Well, the more old-fashioned farmers, traditional farmers, they say, okay, let's not do it with me. You see the pig industry, a lot of farmers have said, okay, this is really has been too much. So we have a subsidy system now for the pig industry where farmers could say, okay, I want to quit, I want to stop with my with my farm, and they're being paid to stop with the farm and not without replacement from governmental support.
Okay. On the flip side, is there a specific sector that's more advanced in making that transition to circular agriculture?
Yeah. I think it's a difficult question to answer because it's so broad and it's so wide. We had big discussions, for instance, with butchers who would say, okay, circular agriculture, would that mean that we have to become a vegetarian? Obviously, that's not the case because we have a specific roles for animals. And then at that point, the vegetarians saw the butchers saw new potential in this whole new circular agricultural system. But you have to explain and find and see the new connections and the new partnerships to make it possible. It's interesting to also include the whole fishery system or the marine ecosystem into this whole circular agricultural system, and that's where you also see well, some resistance at the start as a start, but also new opportunities, for instance, for the mussel sector in the whole marine industry.
Okay. Let's just do one more question here before we move on. And there's two questions that are fairly similar about certification schemes. So do you anticipate that you're going to be setting up certification schemes to better capture the market share? And is, you know, how would that work with respect to what customers are asking for?
Yeah. We are not yet sure whether it should be certification schemes or key performance indicators, or how it should look at what it exactly should look like. But we are working currently on a set of key performing indicators, which includes soil health, soil management. It's a really fundamental basis on the circular agriculture system, but also monitoring the circles of the nutrients in the whole system, monitoring the biodiversity at the farm level, but also at the regional level. So we are building at this very moment together, so science with stakeholders, with policymakers, building on the good monitoring schemes to show to show your level of circularity in your agricultural system.
Okay. Let's continue and go ahead, and I'll continue with these questions as well in the next opportunity.
Okay. So let's start with an example from the open cultivation in circular agriculture. Like I said, at Wageningen University, we have embraced the challenge to develop the knowledge that is required, and to think about what type of systems, what type of new circular systems should we develop to facilitate this circular agriculture. And obviously it's important to start with this open cultivation system. And from the vision of circular agriculture, we can set some boundary conditions. Obviously, new open cultivation systems should be nature inclusive cropping systems. And these systems should have a minimal use of fossil-based fertilizer, preferably none. And we have to minimize the use of pesticides. This means that we should make an optimal use of the arable land for food production. So thinking about that, we could start thinking about crops that grow in strips, for instance. We should think about maybe double purpose crops or double purpose rotations. And with double purpose crops, that I mean to say, okay, maybe we can make part of the crop can be used for food for human, part of the crop can be very effective for the bioeconomy, such that we can make paper out of it, or as feed for animals. But we can also think about the rotations that increase soil health and soil quality. Overall, an open cultivation system should have robust crops with healthy plants and healthy soils. And this is important to realize, that it also means something for the seed sector, because for years we have been developing our seeds to maximize production. And now we need seeds that have different purposes. We have set up a test farm, which we call test farm agroecology and technology. And at this test farm, we try and test all different building blocks which we already have, because we know the impact of greening fertilizers, of landscape elements into a specific area. We have been doing research on strip cropping already. We have been doing tests with fixed pathways for the machinery that we have. We have been doing tests on rotations. But we also have been doing research on agroforestry, on ICT support, on robotization, the use of machinery in the whole system. And we have been thinking about integrated pest management. So what if we combine different parts of these building blocks into an agro-ecosystem? And here below you see it moving from a monocropping system with heavy machinery towards more integrated system, towards a totally nature included agro-ecosystem, making use of the latest innovations in technologies. We've been doing research on these different system since 2 years at this moment. Well, the first thing for us, and that was one of the first conditions, it should be economically viable. So this means that a farmer should have a good income out of it. And we have been calculating strip cropping system versus a monocropping system. And we used the land equivalent ratio for it, which will be the sum of the relative yields. And we have been testing that for different intercropping systems, wheat maize, wheat soybean, fava bean maize. And where you see when the land equivalent ratio is higher than 1, that would mean that the intercropping system would result in a relatively higher yield compared to the monocropping systems. And you can see that some of these intercropping systems, or the strip crop systems, are economically, at least from an harvest point of view, are very sustainable because they result in a higher harvest. Why is that the case? Well, very often because they're less sensitive for diseases, or sometimes because of the co-benefits of the intercropping systems that they have to each related to each other. Well, and they have the positive impacts also on the soil health and the soil quality in relation to each other. So this is an interesting starting point also from the point of view from a farmer. But then let's also have a look at the biodiversity, because circular agriculture also includes looking at biodiversity. Well, first of all, what does it look like, such a strip cropping system? And I like the picture. We took it with a drone. This is what it looks like. One of the strip cropping systems that we have been applying. And we have been looking and measuring for the last 2 years on the abundance of different birds in our agricultural fields. And what you see is the blue is the demonstration area, the gray is a reference area. So demonstration area will be one of our field areas where we do perform trials. This one is a reference area, a normal farm, and this is a strip cultivation area. The strip cultivation area is not only at a research station, but it's also strip cropping at farmers' fields, so which we apply in the actual fields of the farms. What you see in all cases is that within 2 years, the abundance of different species, which are important for the Dutch landscape, is really significantly increased in these areas. And why is that the case? It's the case because also the percentage of individuals of different types of insects in this intercropping system, it's much higher because we are using less pesticides. And because we have this higher number of insects, much more feed is available for the birds such that they can grow their youngsters. Well, if it's economically viable and it's also good for nature, why don't we have it all yet, this strip cropping system? Well, that's partly because it's very labor intensive system. It requires to know several types of crops. You can only manage a specific strip in a specific way. And then another strip you have to manage in a different way. And we need more development in technology, in robots, for instance, or in drones, or in the ICT systems to be able to apply this whole strip cropping system at a large scale. And starting about this type of research, I was in discussion with my son the other day about what to study, how to move forward. And we were in the debate like, okay, farmers for the future, maybe it's a good idea to start studying ICT such that you can become a farmer. So that will be a whole different way of farming. So you will also get different types of farmers with a different knowledge, because you should be able to manage these types of technology in order to apply the strip cropping systems. So for the open cultivation system, we need innovations in seeds, we need innovation in these technologies, but we also need innovation in the way we educate and train our farmers. So for that's what I had to say at this moment about the open cultivation system. I'm curious, I've seen already some questions.
Yeah, there's some good questions. I'm going to ask one that came in earlier today. Somebody was asking about why you would need less area for the same yield in an intercrop system. For example, wouldn't you need room for different types of farm machinery or planters or harvesters to make turns?
Well, we have not looked in this part. We have not looked at the area that you need to make the turns for the different machinery, but we really looked at the potential yield only for the farmers. And looking at the innovations that you need and to make the turns, we are really counting on the developments on technology that you will need. You will have smaller machinery and lighter machinery, allowing also, well, just avoiding soil compaction. So,
and there's a question about this land equivalent ratio, and has it been reproduced all over the Netherlands?
it has been reproduced so far in different cropping systems and different soil types. So we have been reproducing it at clay fields, at sandy fields, at more lush-like fields. So at different zones, but obviously with an intercrop system that fits to the different soil types.
Okay.
So my answer would be yes, but make sure it's 2 years of research.
Okay, and then with respect to this intercropping system, how many different crops are in this strip cropping system? Is that a test farm or was that a commercial production that you were sharing with us?
This one is from a test farm, and this is where we have a group of 4 different crops in a row, 5. But you can do as many as you want, but you have to really think about labor and about which crops are beneficial for each other. So such that you can get out of the strips, you can get also an additional benefit.
Okay. Let me ask one more question. It's not so much on the strip agriculture, but on a similar or another system that might fit into circular agriculture. This person had read an article about a Dutch floating cow farms with fish farms underneath them, which seems like circular agriculture. And could you comment on the viability of this? Is that a gimmick designed to push the envelope on ideas? Or is it actually something that could be part of the solution?
Yeah. We have this Dutch floating farm. It's floating in the harbor near Rotterdam. We have tested the cows in order to avoid them to become seasick, such that they can actually live in a beneficial way on the water. What they do, they collect side flows from the city and feed it to the animals. So they are really part of a circular system. I personally have my doubts whether it can become that big that we can actually feed the whole world with it. However, I do really like how this brings the urban population much closer to food production and to the animals that they eat. Because very often for people in the urban area, a cow is something that they see on a movie or on television, but they never actually physically see.
Let's see, I'm going to ask one more question and then we can move on. And of course, all the questions are being saved, so we'll definitely answer them. But this is, you know, looking at this open cultivation or making these sorts of changes, do you feel it's necessary to incentivize the farmers in order to ensure that they make this transition?
Well, definitely. They will need a whole new machinery. So you have to support them buying this machinery because at the start, at this point, it's still very expensive to buy these robots. So you need to think smart about how to provide your subsidies and how to stimulate farmers to develop new agricultural systems. And that brings us back to this cross of this transition management. So you need to provide some support to accelerate new experiments, which may be experimental space or favorable legislation. At the same time, you have to do something to reduce the current agricultural system, the presence of it, and find a good balance between that. But I would rather have a positive stimulation instead of punishment of the current system.
Okay. Let's go ahead and continue, and we'll continue with the questions as well. Very good questions coming in.
Okay. Let's move on to this one. Then horticulture. The Netherlands, we have a very large greenhouse, large developments in our greenhouses. And one of the very important developments is vertical farming, and I think it's on the rise worldwide. However, it's really nice to see that we can actually provide vertical farming in a 9-story building in Dronten. This is one of the biggest in Europe, which is being built. And the fact that we can create, and it's a commercial built greenhouse, I have to say that one as well. So it's not a research facility, but to provide fresh vegetables in such an urban environment close in the city is really an added benefit for it reduces the transport or the logistics of food to the urban environment. So I think especially in the future where a lot of people will be living in the urban environment, having these type of horticulture potentials is very important to be realized. However, horticulture, this is not yet a circular system because horticulture requires a lot of input, specifically from energy. It's very energy intensive, and it also requires inputs for fertilizers to grow the crops into this horticulture system. So we had the challenge to think about, okay, how do we reach a greenhouse facility which is climate neutral, which doesn't use any additional inputs or no pesticides and no fossil based fertilizers. And therefore we have developed a vision like we say, okay, the greenhouse gas in 2030 should be efficiently, it should be clean, and it should be connected. And we have set up, and recently your Ministry of Agriculture from the US, he opened the facility. We have set up this new research facility where we test production in the greenhouses, which is fossil free. So we have less energy use, which we make use of sustainable energy sources. It's also emission free. So we have closed water loops and no nutrient losses. And it's pesticide free. So we're looking at the maximum of biological control. So this whole system, and it's running now for approximately half a year, different types of crops as sustainable as possible. And it's really a blueprint for greenhouses of the future. However, having a climate neutral greenhouse itself is not sufficient to become a circular greenhouse as well. So in order to think about a new circular greenhouse, we should focus on the connected part of these three elements, and we make sure that we look at the flows that come come into and go out of these greenhouses. So we should have a systematic analysis of all the flows, and that's what we are currently doing, and define the bottlenecks. So how can we make use of the CO2 which comes from livestock into the greenhouses? How can we make sufficient energy of it? And can we think of some crossover systems with open cultivation, or maybe even with fish production, aquaponics? And in order to do that, we are currently setting up new partnerships. So, which is really new, thinking about connected circularity, thinking about new partnerships, thinking about new business opportunities. Because so far I could not have thought of somebody owning greenhouses, discussing with people producing fish about what would be the flow or efficient flow of side flows from to each other, and how they can make benefit from each other. So this is real new economic purposes. And then if you have thought of such a system and start testing different concepts, you should also start thinking, okay, what is then the position in the Netherlands, in the whole landscape, where you would want such an interactive business network, where agriculture is combined with open cultivation, combined with livestock, combined with greenhouses, combined with water management. So these are new decisions which actually affect land use and land use planning in the whole of the Netherlands. So this is what I had to say about greenhouses, and obviously within these greenhouses we do research on optimal crop production, but that was not the focus for me at this moment. Any questions?
There's a few questions. One of them I just thought might be appropriate at this point was in creating the circular economy, and you spoke a little bit about it with respect to the greenhouses. Do you see that different parts of the value chain will need to be vertically integrated to make it work?
Yes, definitely. I think let's say also, well, obviously we need to food producers need to be valued at a specific way in order to make it affordable to have this such a circular systems. But then we need to start integrating also at the level of landscape planning. How do we organize it? Because I don't think we will have totally independent open cultivation system from livestock systems, because we need manure in the future, and manure will be the closing element of the whole cycle. And I will go a little bit deeper into that. But to a certain extent, livestock or maybe manure managing companies will come back as a new product. Will come back into the loops with the open cultivation system. But we also get into supermarkets, for instance, the demand for types of foods where you get maybe a certain label to which extent a certain product is produced in a circular manner. Is that
okay, let's go ahead and
answer you expected?
Yeah, no, I think you talked about a lot of the different aspects of it. I would say let's continue with the talk. We have some high-level questions that I think would be good at the end as well.
Okay. So this is the example from the livestock. I think it's important to start with remembering the roles of the animals in the circular agriculture. The roles of the animals were to transform biomass side streams into animal proteins that can be used for human consumption. For the Netherlands, it's very important to realize that, because at this moment, approximately 30% of our surface is being used to produce feed for animals. So we can make much more use or different use of that land if you want to introduce circular agriculture. And we have been calculating with our models what would be the land and resources needed for human protein production, and what would be the percentage of animal proteins in our diets. And you could see that whilst reducing the land and resources needed for our protein production, we could still increase a little bit the percentage of animal proteins in our diet. So we don't have to become vegetarian all by ourselves and still remain sustainable. But we have to think very clearly, how are we going to feed the animals, and how are we making sure that we still have a high quality of feed for these animals, because we do not want to do it at the cost of animal welfare. We have to assure a high level of animal welfare also in the circular agriculture system. Well, therefore you get a lot of points to consider and to think about. So we have to think about, okay, where do we get our side flows? How do we transport them? And how do we transform all these side flows into high value crops? We have to think about the role of insects in these cycles and how to make sure it's sufficient safe. And finally, we have to think about, okay, what comes out of these animals is not just eggs and meat, but it's also manure. And this manure needs to be managed in a sustainable way as well. And transporting manure is costly, because what you basically transport is some kind of organic materials and a lot of water. So I want to show you here some kind of technological innovations which we are currently applying. It's being paid with European funding, and we look at different feedstocks, so different side flows, pig manure, poultry litter, even sewage sludge, energy crops, or industrial residues, and we look at the way to which extent we can extract them by applying different types of innovative technologies to create biogas, NNK concentrates, organic fibers, or even organic fertilizers. And this is the demonstration plant that we recently opened in the southern part of the Netherlands. And well, how does it work? We have manure coming from the farm, and that can go into a digester to produce biogas, or it can directly go into the decanter. And in the decanter, we extract the liquid fraction from a more solid fraction. And the liquid fraction can go through different types of chemical extraction, being filtrated over a membrane, and then it reduces, well, 50 to 65% of clean water and a kind of organic nitrogen, potassium, which at this moment cannot be used as a fertilizer because it's because of the European law. So it cannot be exported as a fertilizer because it's still considered manure. We want to change the European laws, and that's why we from Wageningen are in discussion at European level about the qualification of organic fertilizers and when you can export them. This is where the big innovation lies, the phosphate stripper. And again, all kind of chemical and technological management issues, but now we are capable to extract phosphate from organic manure, and you have a phosphate fertilizer and an organic soil improver. So all these side products that you can use from your manure will result in either, well, clean water, so less transport needed, because this water can be given to the surface waters. It results in biogas, and it results in new products for the fertilizer marks, which can be then connected to the market or open cultivation. So if you start thinking about circular agriculture and the circle of nutrients, you can start thinking about different inputs. So you can thinking about reducing the nutrient inputs where possible, and that's, for instance, you start thinking in this open cultivation system, to which extent crops can enhance each other. You can start thinking about reusing nutrients directly from organic residues. You can start thinking about recovering nutrients from biomass waste streams that would otherwise result in the oceans. And that's the example that I just showed. You can start thinking about how do you apply these nutrients such that you will have less nutrients losses to the surface waters. I did not show any examples of this, but you can also start thinking about redefining systems where needed. And if you look at the system of the Netherlands at this moment, with the amount of cattle that we have done some calculations, and we see that in order to feed the current cows at the current level, we need so much more phosphate input that we cannot keep these cattle levels at the current level as we have to have them now. And we really have to redefine the system, the way we have our cattle, the amount of cattle that we have in the Netherlands in order to get this nutrient balance closed. So this is what I had to say about livestock.
I think in the interest of time, why don't you go ahead and continue? We have some good high-level questions we can ask at the end.
Okay, then I think this is the most important sheet that I wanted to show you once more, is circular agriculture. It really adds a profit to climate and nature. So we have calculated that with circular agriculture we can regarding climate we can mitigate more CO2 compared than is needed for the climate approval according to Paris. So better use of residual flows for feed results in less emissions. Better use of manure for fertilization results in less emissions. A smarter use of the current fields and meadows results in less mitigation, less emissions, and carbon capture in soils and vegetations ensures carbon storage and climate restoration. However, circular agriculture will have an impact on human diet, so we will have to eat a little bit less meat compared to our current daily meat consumption. I think I will skip this one, and I want to end, because we have little questions. I want to end with the statement that science cannot do it alone. Governance cannot do it alone. We really have to build partnerships in order to assure these transitions, and these partnerships have to happen at different scales. So it can be at a regional scale, finding the transition at regional level, but also at national or international scale to make sure that we develop an agricultural food system that is sustainable and fits within the planetary boundaries.
Very good.
Yeah, questions.
So in the interest of time, I think I'm going to ask a couple higher level questions, but then I want to encourage everyone, if you have additional questions and if you didn't get your question answered here, Dr. Visser's contact information is here at the bottom of the slide, so please email her your questions. This question is, what aspects of the Netherlands' transition to circular agriculture are unique to the nation's size and government structure, and what aspects of the institutional transition do you think can be replicated in larger countries like the United States?
I think I think circular agriculture is unique in every region. In every region, you have to think about what fits for that region. I think the overall concept can easily be replicated throughout the US. I think I have some of the discussions that we had at the Cleantech Summit about the scale or the connection of open cultivation with livestock really shows that also in the US people are already thinking about some of the concepts. What would be unique in the Netherlands is the well, I think it's the governmental support, and the policy support is really needed in order to facilitate this transition. Like I said, you cannot do it alone from science point of view, you cannot do it alone from a farmer's point of view, but it has to be a collaboration. And to say one specific element which is unique for the Netherlands, yeah, I wouldn't know. I think the overall concept can be translated into other countries, but make sure you keep your own unique system, because you have your unique climate and your unique cultures.
One last question here. When the world gets back to normal, somebody was asking, if any of your demonstration facilities are open for tours or to educate the general public?
Yes.
Okay.
We have throughout the Netherlands, with support of the government, we have field farms or trial farms run as a normal farm, but which can be visited by different farmers from the Netherlands or other countries, and we can facilitate these type of meetings. Also, our research stations can be visited, but we have to arrange a meeting. It's not, well, you have to contact me if you would want to come and visit, because we cannot have visitors just coming in, because we have to assure that we have a safe research environment.
Okay, great. So thank you, Dr. Visser, for a really fascinating view into what your country is doing. I think it's really exciting. We have we have some questions that have not been answered, but we will capture those and answer them within the next, we're gonna keep those questions and be able to answer them at least by typing them. And then Dr. Visser's contact information is below. So if you have additional questions, please reach out to her and ask her a question. So thank you everyone for attending, and thank you for the wonderful presentation.
Yeah, thanks for coming to listen. Thank you.
Thank you.
Okay.